Hey, my name is Jason, and for most of this year, I've been working on an open source computer interface that lets you use your breath to trigger keyboard and mouse actions on any computer. I call it the openSip+Puff, and here's what the current prototype looks like. This 3D printed case houses a circuit board that I've designed. On one end of the device is a pressure sensor. This allows you to connect a long vinyl tube that you can find at any hardware store from the device to your mouth. The other end contains a USB port so that you can connect the device to your computer. The computer sees the openSip+Puff as a normal USB keyboard and mouse without any drivers to install. So as you sip and puff on the vinyl tube, the openSip+Puff board automatically analyzes the data and creates keyboard and mouse actions on your computer for you. And the best part is that you can tell the board what it's supposed to do. It can handle simple individual key presses or mouse clicks, keyboard combinations, mouse movements including scroll wheel movements, and even pre-recorded actions like clicking and dragging in a really specific way. So first I want to explain a little bit about why the open source approach and this WyoLum grant is so important for a project like this, but then I'll talk more about the hardware much more in depth. Sip+Puff interfaces have generally been used as assistive technology devices and have been around for a while, but they suffer from all sorts of problems that plague the assistive tech field, like artificially high costs, usually due to lack of competition or smaller demand than other markets. Extremely limited functionality. Many interfaces are just for wheelchair control or offer digital-only inputs. Proprietary and outdated hardware and software interfaces. Expensive black box electronics with strange connectors and very old software sometimes prevent users from upgrading or using the latest tech. And the lack of clear and simple documentation. What's available now is full of trademarks, meaningless hardware descriptions, and unnecessary buzzwords, and it makes it hard to understand just what's going on. For example, one of the cheapest commercial interfaces that I could find costs over $200, requires a specialized hardware interface with its own software interpreter, and is documented in a way that only professionally trained assistive tech experts can really understand how to use it. This would frustrate even the most motivated people without disabilities. So the fact that this technology is intended for a demographic that intimately depends on it is confusing, to say the least. While I can't claim to say that openSip+Puff will fix all these problems, I hope that it's a step in the right direction and that it serves to inspire other makers to start thinking about how they can apply their skills to the assistive tech field. Sip+Puff interfaces are not just useful in assistive technology, they can also be used anytime that you want to perform keyboard or mouse activity while your hands are full, or you just want a fun way to interact with your computer. Say you want to jump or shoot or reload while gaming, or scroll up and down while you're coding for long periods of time, or maybe just change tools when you're using GIMP or Inkscape. With a little help, this device may actually be useful as a musical instrument or expressive drawing tool of some sort. I'd really like to get the device into the hands of curious people who could explore these types of applications with me. So let's talk about hardware. At the heart of the openSip+Puff is an Atmega32U4 with the Arduino Leonardo bootloader flashed onto it. This is what allows the board to connect to your computer as a USB HID device via the USB Mini B connector. An MPX12GP pressure transducer is connected to an instrumentation amplifier, which in turn is connected to the Atmega32U4 on an analog input pin, allowing the microcontroller to read pressure from the user's mouth as a voltage between 0 and 5 volts. The firmware that I've written for the openSip+Puff allows users to easily configure what the system is supposed to do when it detects a sip or a puff from the user. You can represent key presses, mouse clicks, mouse movements, and complex combinations using what I'm calling commands. All of the commands are stored in EEPROM, so you can unplug the device as often as you like and have it behave exactly the same way the next time you plug it in. Right now, I am working on a desktop configuration program that will let users reconfigure their device without ever having to see a line of code or upload sketches to the Arduino IDE. You can control the device's behavior using a simple visual GUI and have the changes automatically be updated in the device's EEPROM. So far, I've developed several rounds of prototypes and have now arrived at a design that I'm confident in. I've developed a comprehensive bill of materials and have some preliminary analysis of how much it would take to actually produce a small run of 100 boards through Seed Studio's Propagate service. I've determined that it would cost just over $2,000 to do this, so this is where the WyoLum Innovation Grant comes in. Not only would the prize money help me bring this project into a real product, but I couldn't think of a better group to hand it out than WyoLum. Having already developed several products on Seed Studio's Propagate service, I feel like you guys could offer some extremely valuable advice and support as I go through this process myself. If you have any questions, please check out the application documents that I've supplied, leave me a comment on the Google Plus post, and if it all sounds cool to you, give me a +1. Thanks!